Hey, this is Mr. Hanson. I've got a shape in front of you. It's a circle, and the shaded part's called a segment. So a segment's just made up of you draw a chord, and then you could shade one side of the circle and one side of the chord within the circle, and that's a segment. So we've talked a little bit about sectors, and that's finding the area of kind of like a slice of pie. This is finding the area if you have a chord that separates two parts of a circle. So that's kind of what we're working on today, is finding the area of a segment. And I had a really difficult time trying to come up with a word problem or a scenario for this. But maybe if you had maybe some kind of a pipe in this segment shape, how much water could you fit through it at once? Or maybe if you were painting a floor with some kind of logo on it, how much paint would be taken up by that segment? I don't know. Those are just kind of the thoughts that came to my mind. So how would you find the area for that piece of the circle? If you're not sure, hopefully you've had a minute to kind of think about it. Go ahead and place a center point on the circle and draw a sector. So if you had that sector, you could probably find the area for the entire sector. But that isn't the entire sector. It is, let's write it down, the sector minus a triangle. And that equals the segment. So let's see if we can maybe come up with some formulas for sectors and triangles, and we'll put those formulas in here and kind of work through this. So you might remember a sector from the last video is pi. No, I'm sorry, not pi. It's just r squared theta over 2. And then for a triangle, it's 1/2 the base times the height. So that's kind of what we're going to look at there. So let's give some measures to this. We're going to have a radius of 6, and this is 135 degrees. Okay, let's find the area of the whole sector. When we're talking about, so we've got r squared, that's going to be 6 squared. And then theta, it would be easier for us to work in radians, so 135, hopefully you're getting good at converting that. That would be pi over 4, 2 pi over 4, 3 pi over 4, so times 3 pi over 4, and times 2. And so I'm going to just run this through the calculator really quick. 6 squared times 3 times pi, and then divided by 4 times 2, that's 8, and we get 42.41. So 42.41 for my sector. And let's take a look at the base times the height. This one's going to be a little trickier, so I'm going to take this triangle out and work with it. Something like that, and something like that. So the base times the height. Let's draw, this is an isosceles triangle because these are both radii here. And so let's draw a perpendicular bisector right down the middle, just like that. It's going to be a 90-degree angle. It's also going to be the altitude. And then if we looked at maybe the area of one triangle, because we've made it a right triangle now, then we can kind of determine, we can double that triangle and find the area for the whole thing. So that's kind of the idea there. This is a 6, and we need to know a little bit more information. If this is 135 degrees here, and it's a 180 in a triangle, let's subtract 135 from 180, we get 45. And then half of 45 is going to be 22 there. So this is going to be 22 degrees here. And now, believe it or not, we're going to have to use the old trigonometry to figure this out. We've got to, so let's just go, we need to find the height. So we'll call the height h right here. Height is h. And we've got the hypotenuse, so the height is like the opposite. So we're going to use sine. So sine of 22 degrees equals h over 6. We can times both sides by 6. So the height's going to be 6 sine 22. 6 sine 22, which is 2.24, and that looks about right. Okay, so now we have 2.24 for the height. I'm just going to plug that in right here, 2.24. Could we also find the base? Let's call this B, the base. So this time we're going to use 6 cosine, let's do it this way. Cosine 22 equals the base over 6. So let's times by 6, times by 6. So we got 6 cosine 22, which is 5.53. Okay, so let's see if we can just figure out the area for all the triangle now that we have these numbers. So I'm going to type in 0.5, that's 1/2, times 5.53, times 2.24, and I get 6.193. So 6.193. And remember, that's just for half of the triangle, so we have to double that. So I'm going to times it by 2. And we get 12.38. So 12.38, and we're going to subtract that from, so 12.38. I'm kind of running out of room. These are my big numbers here. So 42.41 minus 12.38, and I end up with 30.03. Now I think a 135-degree angle would probably be a little more like this, and so you can kind of see that it would take up a little bit more area there, kind of like that. Like this, the whole thing would be, the whole thing all the way around would be 42, and then the triangle would be about 12.38, and it ends up with about 30.03. So there it is, finding the area for a sector. I'm sorry, not a sector, a segment of a circle. The big idea is just take the sector, subtract out a triangle. These both take a little bit of work to get. Sector minus triangle. Might have to do some trigonometry to find the area of the triangle. Hope this was helpful to you. Thank you, and have a very nice day. This is Mr. Hansen signing out.